Chapter 5, Continuity and Differentiability. In the previous sessions, you have seen about the concepts of continuity. So today we'll proceed with differentiability. In the second part, you need to know basic definitions of differentiation, derivative of a function, differentiability of a function. So to understand this, let me tell you something about variables. So in variables, you get two types, that is the dependent variable and independent variable. Dependent variables are those which depend on some other variables. Dependent variables are those which depends on some other variables. For example, you can consider a child and their parents. Normally, children depend on their parents. Here, children is the dependent variable. And second is the independent variable. Independent variables are those which does not depend on other variables. For example, time. Time is considered to be the best independent variable that we get here. And one more example, food and energy. Whenever you are hungry, you consume food. And the quantity of energy that you gain depends upon the amount of food you consume. Lesser the food you consume, less energy you get. More food you consume, more energy you get. So here energy is depending upon the quantity of food you consume. So here energy is the dependent variable and food to be considered as independent variable. So yet another example in mathematics, if you consider, let us take the function y is equal to f of x, that is equal to x square. So here you can give the values of x to be 0, 1, minus 1, 2, minus 2 and so on. So corresponding to values of x, y is taking the values. So here whenever you give x is equal to 0, y is getting the value 0. X is equal to 1, y is equal to 1. So y is depending upon x. So here x is called to be independent variable and y to be dependent variable. With this we are going to define this differentiation, derivative of a function, differentiability of a function. So what is differentiation? So differentiation is just a process of finding the derivative of a function. Differentiation is the process of finding the derivative of a function. So now what do you mean by derivative? The derivative of any function means derivative of any function. It measures the rate at which the function is changing. Derivative is the one which measures the rate at which the function is changing. That means how the function is changing with respect to independent variable, that gives you the derivative. To understand this derivative, let me give you one simple example. Consider a function. Consider a function y is equal to x square plus 3. So initially I am going to fix the value of x. I take x is equal to 1. So when x is equal to 1, what is the value of y? Y will be 1 square plus 3. This will be 4. So when x was 1, the value of y is 4. Suppose if I change the value of x from 1 to 1.1, suppose x is changed from 1 to 1.1, the value of y will be 1.1 square plus 3. This will be 4.21. So here you can see that initial value of x is 1. I have changed it to 1.1. So x is equal to 1.1 ಇದ್ದವಾಗ y is 4.21. So you can see that both x and y value have been changed. So what is the change in value of x? Change in x, it is normally denoted by delta x, or this delta x is 1.1 minus 1, this is 0.1, and change in y is delta y, or this delta y is equal to new value is 4.21 minus first value is 4, this will be 0.21. So now I am going to consider the ratio of these increments, that is delta y divided by delta x. This is delta y is change in the value of y is 0.21 2 1 divided by change in the value of x is 0.1. So you get this to be 2.1. So try for x is equal to 0.9. So when x is equal to 0.9, you get the value of y to be 3.81. 3.81. So delta y by delta x, in this case you will get 1.9. You can check out for this. You will get delta y by delta x, and delta y by delta x you will get 1.9. 1.9. Now when delta x, that means the change in the value of x, when it is made sufficiently small, either it may be positive or negative, then this delta y by delta x, ಈ ratio ಏನದಲ್ಲ, this will be tending towards the value 2. Delta y by delta x will be tending towards 2, and this value is called the derivative of y with respect to x. This value, this 2, is called the derivative of y with respect to x when x is equal to 1. At initial point we had taken x is equal to 1. So when x is equal to 1, the derivative of this function y is equal to x square plus 3, the derivative of this function at x is equal to 1 will be 2. They will be 2. So you can say that if y is equal to x square plus 3 is a function, then the derivative of this, then derivative of y with respect to x, then the derivative of y with respect to x at x is equal to 1 is 2. Normally we denote this by dy by dx is 2 when x is equal to 1. Now we see the definition of derivative in general. If y is equal to f of x is a function, then the derivative of f at point x is equal to a is given by limit of f of x minus f of a divided by x minus a as x tends to a. If this limit exists finitely, then we call this to be the derivative of the function f of x. This is normally denoted by f dash of a. Therefore the derivative of f of x at a is f dash of a given by limit of function f of x minus f of a divided by x minus a as x tends to a. This will be the definition of derivative of a function. Derivative of a function at x is equal to a. Now we see differentiability of a function. A function f is said to be differentiable at a point a if left hand derivative at a is equal to right hand derivative at a. If the left hand derivative at a is equal to right hand derivative at that point a, then we say that the function is differentiable at the given point x is equal to a. So left hand derivative is given by limit of the function f of x minus f of a divided by x minus a as x tends to a minus, which is limit. As in case of limits, if you want to calculate left hand limit, you are replacing x by a minus h. In the same case, in order to calculate left hand derivative, here x tends to a minus, you need to replace x by a minus h. F of a minus h minus f of a divided by minus h as h tends to 0. This will give you left hand derivative, and in the same way right hand derivative is limit of the function f of x minus f of a divided by x minus a as x tends to a plus. So this could be written as limit of the function f of a plus h minus f of a divided by h as h tends to 0. So if left hand derivative is equal to right hand derivative, then we say that the function is differentiable at the given point x is equal to a. So also a function f of x is said to be differentiable at a given point x is equal to a if it is possible for you to draw a unique tangent to the graph of y is equal to f of x corresponding to x is equal to a. So if you know the graph of the function y is equal to f of x and corresponding to the point x is equal to a, in that point you must be able to draw a unique tangent. If it is possible to do such, then that function will be differentiable. That is, there should not be any sharp corner of the graph corresponding to the point x is equal to a. Corresponding to x is equal to a, if you are having any sharp edge, then that function is not differentiable at that point.